Okay, so today we are going to talk about context tables, graphs, and equations and how the four of them relate. So on your problem, sometimes you'll get a context or a table or a graph or an equation. You'll get one of the pieces, and then you need to fill out the other three pieces of the box that match that information that you have. Okay, so this first context says you and your friends go to the state fair. It costs $5 to get into the fair and $3 each time you go on a ride. So with that information, we're going to create a table, graph, and an equation. So the equation is the easiest place to start from our information. What we're going to do is we want to write it in the form of y equals mx plus b, where m is our slope, or how things are changing, and our b is our y-intercept, or our beginning point. Okay, so on this little context, I'm going to look for something that could be changing each time and something that is constant. So the change each time would be $3 for each ride that we go on. And then the y-intercept, our b, our set value, is you have to pay $5 no matter what to get into the state fair, for this particular state fair. So I'm going to take these two pieces of information and plug them into my m and my b, and then I will have my equation. So my slope is how much it's changing, so each time I go on a ride, I have to pay $3 more, and then I have to pay a flat $5 just to get in. So here's my equation, y equals 3x plus 5. Okay, so my table, your table is always set up with x values on the left and y values on the right. You should start with 0 because you can't have negative rides on a ride, and you can't, like, the fair doesn't pay you money to go and see them. Although that would be super nice. Okay, so I just continued on my table, 0, 1, 2, 3, 4, 5, 6, and then I'm going to see what happens with my x values and figure out what my new y value would be. So if I don't go on any rides, then I only have to pay $5 to get in. But remember, each time I go on one ride or an additional ride, I have to pay $3 per additional ride we go on. So I've paid $5 to go on 0 rides. After I've gone on one ride, I need to add $3 more because I've paid for one of these rides. So now I'm up to $8 that I've spent. Well, on this one, number 2, if I've gone on 2 rides, I have already spent $8 and I've spent an additional $3. So that puts me up at 11 because it's $3 per ride. Okay, so then we keep going and continue on our table. And once it's all done, then we can graph. Now these graphs are kind of itty-bitty, and they have also these sides over here, and these sides are not necessary for us. And the reason is because you can't have negative rides, and you can't get paid to go to the fair, unfortunately. Okay, so I set up my grid lines. I'm going to change this grid to help me better graph it. We're going to ignore the inside grid lines, and we're going to redraw them on the outside. That way we have more room. Okay, I'm going to graph my equation or my table. Either way, you can look at your table of values or you can graph the equation. So I start at 0 and then I go up 1, 2, 3, 4, 5. My slope, how much I'm changing each time or how much money I have to pay each time I ride a ride, is $3. So I start at $5 and then I rode one ride, so I have to go up 1, 2, $3 and then to the right 1 because I've rode one ride and I've spent an extra $3. Then as well, I have to do the same thing for the second ride I go on. So up 1, 2, $3 and then over 1. So there's my graph of my equation. Let's look at another problem. On this problem, we are only given the table and we aren't given any information about the context, the graph, or the equation. So we need to use the table to get our 3 pieces of information that we're missing. So notice on the table, my x value is always on the left and my y value is always on the right. My x value is the time in hours, and then my cost is over on the right-hand side. So the pieces of information that I do know, that no matter what, whenever I start or before I start counting the hours, at 0 hours, I have to pay $7. Then from here, 7 to 9, I've increased by 2. Same thing from 9 to 11, increased by 2. 11 to 13, increased by 2. So my rate of change is $2. So I paid my $7 just to begin, and then each hour after that, I have to pay an additional $2. So an example of a story that we could write would be maybe a story about a trampoline facility. So we go to this trampoline place. So trampoline cost $7 to get in and $2 each hour to bounce. So there's a context, little story that has our 2 pieces of information from our table. That's really important. Oh, sorry.
Savannah Frisbee, your cotter pool is waiting for you out front. Make it out front, Savannah Frisbee.
Sorry, announcements. Okay, anyways, so then we can write the equation. So the equation is y equals mx plus b. So our m is our slope. That's how much we're increasing each time. So we're going up by 2 or decreasing. And then our b is our beginning point. Well, we started with $7. We had to pay that no matter what. Okay, now we can graph our equation. Again, on our grid, I'm going to extend out our lines and redraw our axes. Oh, I forgot to label. Okay, we'll label this one. So I need to start at 7. I need to begin at 7 with my y-intercept. So up 1, 2, 3, 4, 5, 6, 7. And then my slope is 2 over 1. You can always put a 1 underneath it if it's positive. Or you could just graph your ordered pairs, whatever you'd like to do. So I have a rise of 2 and a run of 1. Rise 2 over 1. Okay, now, when I started at 7 here, that represented how much money I had to pay. So on the left-hand side, it's money. Also, you can see Y stands for cost. Then every time I moved across 1, it was per hour that I was bouncing. So this is hours. And again, my X up here, it says hours with my X. So I have labeled my graph appropriately. So don't forget to label your graph. Now, these two were both examples of increasing. Sometimes you have decreasing. For example, I'm not going to do the whole thing, but on your homework, you had to do number 4. And on here, it says there are 300 fish in a pond. A crocodile is loose in the pond and is eating the fish. Each day, the crocodile eats 15 fish. So on this example, or this context, we are actually losing fish because the crocodile is eating them. So we're going to have a negative slope. We have a max number of 300 fish in a pond. Okay, can't get any more than that. So just be really careful with this one. I'll write the equation for you. Okay, so the equation, y equals, so the max number, our starting point of fish is 300. So that is going to be our b value. Now I'm losing fish because of that silly crocodile. And he's eating 15 fish each day. Sorry, I was trying to figure out what my other number was, or my other, anyways. Okay, so he's losing 15 fish each day, and I'm not sure how many days we're going to be looking at. And we started with 300 fish. So this is how you would write this equation for this context. And you could even write these the other way if that made more sense, that we started with 300 fish and then we took away 15 fish each day. These two equations mean the same thing, but we're more used to seeing the slope first in front of the y-intercept when we graph. So from here, we can start and make our table of values, x and y. X would always start with 0. And then the y value, if we have 0 days have passed, how many fish would we have here? If you have any questions, please talk to one of your teachers and we can help you. Be more than happy to help you.